Welcome back. For our next keynote, I am honored to introduce Jay Kreps, CEO and co-founder of Confluent and one of the original authors of Apache Kafka, talking to us about data mesh, driving modern architectures with Kafka.
Hey everyone, I'm really happy to be here. I'm going to be talking today about an idea that's been coming to prominence, the idea of a data mesh. And so, well, what is that? Let me back up and start with an idea that's maybe even more fundamental, which is the idea of event data and event streams. And so what is an event? Well, it's just something that happened, but it's a really different way of thinking about data. Instead of thinking of a kind of stored pile of data that sits in one place where you look up little bits of it, at some point in time. This is a stream of everything that's happening at any given time that's kind of goes on and on forever. And this data could represent sales occurring in a business. It could represent things happening out in the world. It could represent anything. And when we think about event data, it really has two uses, two ways of interpreting it. One is it can be used as a kind of notification that triggers an application. And the other is it can be used as data. It can be something where you actually look at the details. So in this sales example that I talked about, this could be notifying an application a sale has taken place, and that application might go fulfill the order. Or it could deliver data about the sale. And what the application may be doing is analyzing that data and computing statistics on what's sold and what's not sold. So these event streams can really be used for both. And there's really two movements that I think have kind of grown up out of this area. There's a strong analogy between them. Both benefit from event streams. And both are actually focused on how to scale software engineering in different domains. So the first is the move towards microservices, the idea that you want to be able to divide up your application into pieces and have it work independently. And the other is the idea of data mesh. I'm going to talk about both of these because I think for most people, microservices has been around a little longer. People may be more familiar with it, whereas the idea of data mesh may be newer. But they're actually relatively similar to each other. The idea of microservices is in the application space. How can we chop up our business logic and really take advantage of this to be able to develop faster, deploy applications in parts that can maybe move more agilely. In the case of data mesh, this is more about data. How can we federate out data and share it across an organization? Both of these are ultimately about decentralization, and they bring together some of the people aspects and some of the technology aspects of what we do. And so I'll draw out this analogy in a little more detail for those who haven't seen it. Microservices are all about communication. I talked about event streams as being part of this. This is how you can build an asynchronous microservice. So an event occurs, and it can actually trigger logic in other applications, in other parts of the company. Those parts can evolve over time. You may add new ones. You may remove old ones. And this is ultimately a way of orchestrating the behavior across these applications. When we look at the use of data and of analytics, this is an area that also has kind of a monolith problem. And the classic architecture for data flow in an organization was something that was pretty simple. The idea was you would have a bunch of individual applications that would largely stand alone, and you would pull data out of them periodically, maybe at the end of the day, and you would load it into some kind of data warehouse, which would serve all the analytics use cases, the reports, and ad hoc queries and other use cases. And so there's really a limited set of sources that are pretty homogeneous, relational databases. There is kind of a single centralized place that data goes to for analysis, the one big data warehouse, and a limited set of uses for analytics. And so that's kind of the classic architecture for using data, and that's really changed over time. The world has become a little bit more complicated. If we ask a company in reality to draw out their data flow, what goes from where to where, it tends to look a little bit more like this, where there are hundreds of applications and databases and data stores, microservices, SaaS layers. All of these own little bits of data. And the world of analytics has gotten more complicated as well. There's data warehouses, but also data lakes, analytics tools, and specialized data stores that serve different use cases that didn't even exist at the time that more classic architecture was built. And if you try and attack this problem, if you try and attack the modern problem in the same way, using the same kind of people and process as the older architecture, you get a huge bottleneck. And this is something a number of companies have observed, that if there's a single team that is responsible for all the integration of data, and you have a more modern architecture that involves lots of data in lots of places, that team is just not going to be able to scale with the rest of the organization. They're not going to be able to get every use case right. They're not going to be able to capture the right model for data in every place. They actually just can't keep up. It's hopeless. And this is something that has really motivated the move towards streaming and event streams, the idea of reusing data. This is something that's helped drive the rise of Apache Kafka. This is something that allows many different applications to plug into these event streams and feed off of them. So it's no longer a bunch of independent applications that don't need to exchange data or communicate in any way. It's no longer a single centralized data warehouse. Instead, there's many application use cases that need to exchange data, the search indexes and data stores and other lines of business. And there's a much richer world of analytics and ways of harnessing data, the machine learning use cases, the more production analytics use cases, as well as the classic data warehousing. And all of that has to coexist. And this architecture allows us to actually share data more freely across. And so what this talk is going to be about is, how do you make this real? What are some of the practices that make this actually approachable? I think whenever you try and think about how you're going to roll out technology in the large across an organization, across multiple teams, that's ultimately a function of both people and software, and they have to work together. They both actually have to follow the same principles. If the people are trying to do one thing, but the software was built to do another thing, it just doesn't work. And this is where the idea of a data mesh has come around. It's a really compelling set of principles that we can kind of align around. And this is an idea that was kind of pioneered by Zhamak Dehghani, who kind of laid this out in a blog post and set of other talks around this. So I'm going to go through these principles in a particular order. I'm going to divide it up a little bit into two sections, a bit about how data is produced, how can you publish out data to the rest of the organization, and then a bit about how it's consumed. How can other parts of the organization tap in? And I'm going to go through these 4 principles and try and explain a little bit about how companies can actually do this. This is something that at Confluent we've put a lot of work into. It's something the larger Kafka community has put a lot into. And it's something that I think is a huge part of what the movement around Druid and more real-time uses of data have really benefited from and been a part of as well. So I'll talk about these 4 ideas. I'm going to start with organizing how data is produced. And there's this idea of domain ownership and data as a product. And these are a little bit abstract, but the idea is actually really straightforward. So instead of having a centralized data team that's responsible for scraping all the data out of all the different systems and modeling it exactly the right way, that captures all the relevant things about the business and is easy to take advantage of, instead we're going to federate that. We're going to decentralize that. And we're going to say, look, in our company, there's different areas, there's different kind of product areas that are going to have owners. And the product owner in an area is going to be responsible not just for the UI for their product, not just for the APIs for their product, but also for the data that comes out. And that data has to be something that's usable and consumable by the rest of the organization. And if we get that right, if we can actually get the kind of boundaries right and agree on how we're going to produce data out for the rest of the organization, then we can really scale how that is consumed, right? So, what can that boundary be? How can we make that API? And how can we make it good? Well, part of this is really thinking of the data as a product, as an output, trying to design What will be usable? What do people actually need? What are the use cases? That kind of design-oriented thinking is really critical for this to be successful. But you also need to pick some kind of mechanism. What are we actually publishing? How do people get it? When is it available? The simplest thing that might work is, hey, we're going to dump out some CSV files from all our database tables, and we'll put them somewhere where people can pick it up. And the question you might ask is, well, is that good enough? Is that going to be a reliable exchange mechanism across a company? And I think it doesn't quite get you there. And the reason it doesn't quite get you there is it doesn't really check all the boxes for the use of data. And one of the reasons that Kafka has been really popular as this kind of data exchange mechanism is a set of things. First of all, is real time. It can support real-time use cases for data, the kind of production-oriented use cases. I talked about how there was maybe a point in time where applications kind of stood alone. Increasingly now, applications all need to exchange data, feed off of each other. There are production use cases for data, and those usually are things that happen as the business operates. They happen in real time. Next, it's scalable. It can actually grow with the business, with the number of use cases. You can scale it out. And it's multi-subscriber. Different applications can come and go. They can tap into different data streams. And it's universal. It can serve not just application use cases, but also capture changes from databases, capture pure events about what your customers or users may be doing. These are some of the reasons that increasingly the modern data ecosystem is built around event streams and increasingly around Kafka. And this pairing of Kafka and Druid, this is something that we've seen as incredibly popular out in the larger ecosystem. This really opens up a whole new category of use cases. If the idea of a data warehouse was this kind of ad hoc deep dive analytics where a business analyst would go in and run a bunch of queries, many of the modern use cases we see are actually quite different, where there's sophisticated use of data, but it has to happen in real time as part of a customer experience that's delivered with low latency. And the same thing that might feed into a data lake or an offline system also has to feed into this much more real-time system. And this is one of the key use cases we see in a lot of our customers. And it turns out not only in our customers, inside of Confluent, we also have this use case as well. So if you use Confluent Cloud, there's not only the ability to spin up Kafka clusters, but also real-time monitoring on those clusters. What's actually happening? What is the usage? What's the lag of different consumers? All of those stats actually go into a big internal observability Kafka cluster and a really sizable Druid cluster. So that cluster ingests over 3.5 million events per second and handles hundreds of queries on top of that. And this allows us to have real-time insight into the operation of thousands of these different clusters. We run a set of sophisticated algorithms against this to try and proactively detect problems that may emerge before any of our customers would see it. We use it to power alerts that would go out to those customers, as well as internal visibility and dashboards for ourselves. It really is a key aspect of how we run our cloud at scale. And so, this larger idea of a data mesh, is this better? Is this a better way to produce data? Well, it does solve a lot of the problems that I talked about before. If we get this right, there's no longer a centralized data team that has to go around and understand each use case and schedule time to get that data and model it correctly. Now, every time you add a product initiative, that team has capacity, and they're going to be the ones responsible for getting the right data out. And they should know what the right data is, because they're the people who understand that part of the business. And this actually allows the data and the use cases for data to evolve at the pace of the business. If somebody else needs to tap into a stream, they can do that. They don't have to schedule additional work from some centralized data team to build that integration. They can just tap in and consume those streams and use them. And done right, this can help alleviate that kind of long line of people waiting for data. And this is something a lot of people have experienced. If you have some project that depends on data, oftentimes, a big part of the struggle is just getting it. So, done right, this idea of a data mesh really can help scale the production of data. But to get it right, you have to actually solve some of the problems around how data is consumed. You have to be able to actually make this usable. It's not enough to just have lots of people producing lots of data if it's in an unusable format. If people can't really take advantage of that. And this is where the second two principles are going to come into play. So the first of these is self-service. How can we actually make it the case that you can have the infrastructure for real-time data on demand, and that customers can just tap into the data that they need as they need it? How can we make this a truly self-service thing? If we can't do that, and if at the end of the day you still have to go file some ticket with some infrastructure organization that has to go do some work to provision capacity, we will have kind of failed. We won't really have achieved the goals that we have. And I think a huge part of making this work properly is the cloud. And this has been a huge focus for us at Confluent. So I'm going to talk a little bit about some of the work we've tried to do to make this idea really self-service. And the first part of this is just the obvious, it has to be just dead simple to provision, capacity, to get a new cluster, to be able to expand and contract as you need that. That has to be something that any team in the company can actually take advantage of without a ton of work. And the use of data, it's not just a matter of being able to read and write from Kafka. The ability to connect to other systems, to tap into the data that they may have, the ability to do transformations so that you can produce data in the right format that others are depending on, even as that data may change underlying. That's really important. So the stream processing layer that's part of that KSQL helps with these real-time transformations. And the connections into the rest of the ecosystem. So we have dozens of these different connectors which allow you to plug into different technologies that may need this. This is obviously a critical thing. If different teams are going to want to tap into this data, there can't be a whole integration project for each of those. So this focus on making it self-service is really critical to getting this right. But it's not just the developer side of access, it's also the operations. It has to be the case that the technology can actually scale with the organization, that you don't have to think about provisioning, storage for each use case, that you don't have to think about the balance of the data within the cluster, that it's easy to expand if you need more. And this is a set of capabilities that we've put a lot of effort into trying to get right. Really making a truly fully managed cloud offering, something where storage can expand elastically as you need more, where you can elastically expand the capacity to handle more and more throughput, where data is automatically balanced within the cluster. If you don't get these things right and you try to actually decentralize, what you end up doing is effectively forcing every team in the company to get their own infrastructure team to help manage it. It really doesn't work. And the last part of this that we've put a great deal of effort into is how to make it really easy to do this across different environments. It's inevitably the case that a modern company is complicated. There's more than one geographical region. There's often more than one cloud. There may be cloud and on-premise. There's many different things that have to plug together, and data isn't always in the place that you want it to be. And so, how can you have the Kafka clusters in these different areas? How can you have data stream in real time between them? We've put a lot of effort into what we call cluster linking, which makes this, very, very easy to kind of programmatically declare where you want data to flow to and have it flow in real time between different clouds, between cloud and on-premise, between different clusters that are geographically distributed around the world. This really makes this idea of a data mesh something that can span all the parts of the organization and that any application or system anywhere can tap into. So to illustrate this idea, Addison, who's a product manager at Confluent, is going to demo this capability and show how easy it is to create a connection between different clusters, mirror data continuously and in real time, and actually have a data mesh that spans environments. Addison?
When we were building Confluent Cloud, we knew that we needed to abstract away a lot of the complexity that comes with using Kafka to make sure you could focus on your business. We needed to make it self-service via a UI, a CLI, and a RESTful HTTP interface. We needed to take care of all the upgrades, patches, and data balancing, make it elastic, make scaling storage a thing of the past with a new storage engine. The provisioning of connectors and the scaling of tasks needed to be point and click. We also needed to add stream processing with KSQLDB. When it came time to tackle geo-replication, we knew we couldn't take the same connect-based approach that is used today. We needed to make a more intuitive way to handle cluster-to-cluster geo-replication that doesn't require a PhD in networking. We asked the question, can geo-replication be as easy as creating a topic? Turns out it can. Let me show you with a quick inventory management demo. I have a dedicated cluster running in GCP in US East 1. This will act as our centralized inventory cluster. I have two other clusters, one in Azure in Europe and another in AWS running on US West 2. We need to share inventory data with the centralized cluster on GCP. Now we could set up a connect cluster, manage the tasks, and manage the offsets as the data gets replicated from one cluster to another. But that is too complex and not as performant as it could be. Let's see how cluster linking makes this easier by mirroring data from one cluster to another, byte for byte, with no extra moving parts. I'm going to use the Confluent Cloud CLI cluster linking command to create two links between our two warehouse clusters and our centralized cluster in GCP. The first link we'll create is from our US warehouse cluster to the logistics cluster. Now let's run that command again, but from Europe to our centralized logistics cluster. That's it, all linked up. Now I just have to choose what topics I want to mirror from one cluster to another over these links. To mirror over the data from the two clusters, all we have to do is create a special kind of topic called a mirror topic. This topic is a byte for byte mirror of the data in our source topic. That means offsets are mirrored perfectly, byte for byte, as I move the data from one cluster to another. And I don't have to worry about creating a second source of truth. All the offsets are the same. Creating a mirrored topic is easy using the Confluent Cloud CLI or REST API. Create it with the Confluent Cloud Kafka mirror create command. Now that those mirrored topics are created, the data is flowing over the links. Now all we have to do is consume these mirrored topics like we would any other topic. We can see all the data flowing from our warehouse clusters on Azure and AWS to our centralized cluster on GCP. That's it. Cloud native, offset preserving, global geo-replication across environments, all in about 60 seconds. Cluster linking is generally available in Confluent Cloud, so go check it out.
So that's a little bit about the self-service capabilities. This is absolutely essential if you want to have an organization at large be able to tap into data, to be able to produce and consume on demand, to be able to do that without getting bogged down in all the intricate details of infrastructure and the mechanics of data exchange. We want to make that as easy and frictionless as possible so teams don't end up all blocked on each other. The second part of really getting data consumption right that we have to nail is governance. Now, governance may sound like a heavy-handed thing, but ultimately there's a set of questions about data that you have to be able to answer. So, where is a particular piece of data? What does it mean? What are the fields? Who's responsible for that? Is it correct? Is it complete? How did it get there? If you can't answer these things, then you have a big problem. Your data may be untrustworthy. You may not be able to build against it. And in a way, this move towards something decentralized complicates this problem. Who's the central authority who can tell us all of this? This is a problem that can be solved with good tooling, though. We can actually build out tooling that tries to answer these questions, that says, hey, where do I find this? What does it mean? How can I actually understand this field or that field? This is a set of capabilities we've seen customers need over and over again. So this is something that we've put a lot of effort into. And we have a really interesting new product that we've just launched around this. One of our product managers, David, is going to demo some of these capabilities of how you govern data across an organization. How can you actually reason about where it comes from and where it goes to? He's going to show off some of how we're enabling customers to do this. And this is something we learned from our customers, from the tooling that they had built and from the use cases that we had heard.
So for this demo, we're going to put ourselves in the shoes of Francisco. Francisco is an engineer on the data team of the United States Aviation Monitoring Department, also known as FlyWatch. So you, Francisco, and your team, you have a very important job, taking care of the data that keeps us all safe in the skies. So this is fast and furious, real-time sensitive data that informs the position of every aircraft in the US airspace. And naturally, Kafka is this data backbone. All right, so let's do this. Great, so we are now online and looking at the FlyWatch Monitoring Control Center. On the screen are all the airport applications consuming from their respective topics in Confluent Cloud. As we can see, the LGA LaGuardia application screen is blank. So let's quickly jump to Confluent Cloud to investigate more. First thing I'll do is use the new stream lineage tool to visualize and understand how event streams are flowing through Confluent. For the first time, I can follow the lineage of my data and stop by anywhere along the way to get more information. Each node on the graph represents a topic or an application that is producing or consuming from a topic like a connector, a KSQLDB query, or your own coded application, and the edges represents the data flowing between them. Note that this graph is built automatically from the activity of producers and consumers of data, with no additional work or instrumentation needed from my side. Confluent is connecting the dots for me. So, starting from the left, I can see all the aircrafts publishing their own location to a topic named aircraft. These are Java applications configured with the Kafka client ID as the actual aircraft ID. Then, subscribing from this topic, I have a Kafka Streams application that is filtering out any PII data like the pilot name. In fact, this application is using the new tagging feature for schema fields to determine which values should be masked. Next, I have a series of KSQLDB queries routing these events to the respective airport topics. Finally, I can see all the FlyWatch applications I showed on the initial control center screen consuming from these topics. One thing I notice immediately is that the LaGuardia topic is not showing up on my lineage. Something must be off with this KSQLDB query. So, let me go ahead and inspect this node. Going to the query clause, I can see we are using a field called TrueTrack to filter events. This seems like a good follow-up for me. Using the new stream catalog functionalities, I can now search and discover what TrueTrack is. The catalog takes me to the schema of this field, where I can learn more about this data definition. Schemas are incredibly powerful for governing data in motion. They don't just make explicit the data contracts between producers and consumers, but also power data discoverability since they are a primary source of data information. I found that TrueTrack is tagged as deprecated, and now I have context for why the KSQLDB query is failing. Let me also add the tag do not use to make it super clear for other users to come. Great, so now I can ping the owner of this KSQLDB query to take it from here. This is the end of the story. I used the new self-service governance tools on the platform to successfully help me out this Friday night. I'm super happy, Streams the Chihuahua is barking in happiness, my boss is happy, everyone is happy. All of this is now live in your Confluent Cloud, so please go and check it out.
Thank you, David. Well, that's a little bit about federated governance. If you get that right, and if you've mastered the aspects of data production and data consumption, this is what can really enable the use of data in the large. It's what can really unlock data for all the new use cases for the next generation data stores like Druid that want to be able to consume it and use it, and that you want to build around for the next new applications and use cases that want to tap into it. This is something that can really help data get connected across an organization. And something that's really worth putting the effort into getting right in any company. And this is something we've been excited to watch flourish out in the world. This idea of a data mesh is something I think is really just starting to take hold. You'll hear about it now in a lot of discussions around data. People talking about it, people doing it, the success, some of the difficulties. And so hopefully this adds to some of the ideas of how to make it real in your environment. Thank you all very much.